Q&A, Ask Me Anything with Rodrigo, the principal software engineer who is in charge of the configuration cache and kind of help organize this entire hackathon to make sure it's working and goes through all the reviews and whatnot. And so let's go ahead and let's get started. Okay. So we are 1 week through the hackathon. This is a month-long event for the entire month of September, and after just 1 week, we are halfway done with all of the possible issues. So if
Wow.
you're looking forward to contributing, then you got to get in there pretty fast. So by the numbers, there were 28 total available issues. So 28 things to work on with an entire range from pretty easy to a little bit more difficult. And we have now 12 of those issues are completely finished and merged. That is amazing. Yeah. There are 10 issues that are still unclaimed and available for people to jump in and attack. 4 issues are claimed and being worked on at this moment. 2 issues are still in the review process. We're working with those collaborators back and forth to make sure that their issue gets everything. It's a great learning process for everyone that's done it. And a total of 13 people have contributed to the Configuration Cache Hackathon. So that's pretty good numbers considering, our nice and small community. Now, what are you competing for? Well, remember that we have anyone that has the accepted PR gets this amazing Configuration Cache t-shirt. And so right now we've had 12 finished ones. So that means, if all of those are different contributors, that's 12 different t-shirts go out. Now, stay in the lookout for our Twitter channel and our Slack channel because when we come near a close, if all of the issues close or we reach the end of September, then the community is going to vote on some of the best PRs because not all of the PRs are the same. The goal with this is to get that stable configuration cache, and all of the closed PRs achieve our direction towards that goal, but some are pretty cool and have novel solutions. And
Yes.
so we're going to vote, and I hope you vote with us. The top 3 PRs get to choose which one of the configuration cache t-shirts they want. And so they get some pretty cool swag at the end of it. Okay, so Rodrigo, do you have some more details about kind of how the configuration cache is going?
Yes. Yes. Yeah, it's been amazing response from the community. So that's great. We've been having some very productive discussions and realizing during the process that we still don't have like very clear guidance on some of these issues. So that it's great to be talking to the community and sorting these things out. And I guess before we have questions, I should or could go through some of these PRs and just discuss what we have been doing so far, what's good about them, and maybe things that we're still not completely sure moving forward. What do you think? Yeah,
That sounds like a
cool.
great plan.
So let's go there. So I'm gonna look at the PRs that we have already completed the full workflow. We still have one going through the CI pipeline now, but we consider it done, so it's all good. It's being approved. So it's just some hiccups. So let's see what we have here. So in no particular order, right? I'm gonna just look at a few of those PRs. So this one is about transitive dependencies. Let's see what it's all about. Yeah. So this is a pretty common issue, right? So probably one of the most common ones, if not the most common one, when you have a task, in this case, an ad hoc task, in a task action, do last, do first, or any of these other actions, and access one of these configuration objects at execution time. Right? So the solution here, as you probably know by now, watching these videos and participating in the hackathon, is to move right the capture of this values that we want to use at execution time to happen during the configuration phase, right? So tasks.register, this first configuration block runs at the configuration phase, and the do less block will run at the execution phase, right? So what we're doing here, so before we were accessing the configurations property at execution time, and that's no longer allowed, right? We can no longer access either the project object or the script object during the execution phase. So we have to move that access to the configuration phase. So with Groovy, it's all good and dandy because Groovy, I mean the Groovy DSL is based on this eager model, right? The original Gradle model where collection members, these extensible members, right? Configuration like runtime class path. It's a member of the configurations collection. And here we can access the configuration eagerly. We just do configurations.runtime class path, and runtime class path is a configuration object. And here in Kotlin, you can see there's something different here. And that's because for the Kotlin DSL, we took this decision early on that all the collection facilities, or like all the synthetic sugar, so to speak, in the Kotlin DSL would be focusing on this lazy configuration model, right? To like the configuration avoidance model, as it sometimes is called, where we avoid instantiating, realizing objects unless they are actually needed to satisfy a particular, to fulfill a particular request, right? So here we're doing configurations.runtime class path.get, because runtime class path at this point here in the Kotlin DSL is a provider of configuration, which is kind of a funny thing, right? It's kind of odd in the Gradle model, and you can see that when you interact with configurations, more, right, than when you interact with other objects, is that because configuration itself, the configuration type, the configuration object is a lazy object, right? It does things on demand. So you only resolve things if you actually try to access files and things like that. So we have a lazy collection of a lazy type, right? So that makes it a bit peculiar like that. Yeah.
Before you go on, can you talk about what that lazy type means a little bit more, and why that's kind of cool?
Yeah. So in Gradle, we have these collections, right? The containers we call the named domain object containers. So like the task container, right? When you say tasks.register like this, right? So tasks is one of these lazy containers. So all these collections that are exposed in the Gradle models, right? They are lazy. Lazy means they don't actually try to run anything or instantiate any objects unless they are actually requested, right, for during a particular Gradle execution. So here I'm doing tasks.register. So that means I'm telling Gradle, hey, there's a task with this name, and here's how you would go about configuring that task for me, right? And it's the same for configuration. So when you create a configuration object, right, you are also adding these objects to this lazy container called configurations in that case, right? And the idea here is that unless you actually need to run like all this configuration code, right, because we're actually running print artifacts or some task that then depends on print artifacts, right? So unless we are running some code, some Gradle request, some Gradle build that needs print artifacts, we won't execute any of this code, right? And that's what's cool about this, is that then we get faster configuration times, even like without the configuration cache in the picture, right? So the configuration cache is about speeding up the next build after the configuration phase has executed. And then with lazy containers, with these lazy collections, it's about avoiding all the configuration work we can avoid during the configuration phase. So we're still running the configuration phase, but if you never requested the print artifacts task, for example, in this build script, this code would never run, right? And that's why we have the lazy configuration model. It's basically to avoid work at configuration time. At Gradle, we're pretty like focus on avoiding work, and I mean avoiding work that would run at build time, if you know what I mean. So anything we can do to speed up the builds. So yeah, is that a satisfactory answer, Amanda?
That was a great answer, and anything to get away with not doing work, right?
Yes. So I think this will be a common theme here. Like when we look at this snippet side by side, right? When we look at the Groovy script and the Kotlin script side by side, this is one of the things we'll be noticing, how the Groovy version, right? The Groovy DSL tends to favor the eager configuration model. It's not a rule, right? It's mainly like the syntactic sugar of the Groovy DSL is using most of the time the eager configuration model, and the syntactic sugar on the Kotlin DSL side favors the lazy configuration model. And we're going to see some of these differences. Yeah, so that's a pretty straightforward change, right? So thanks. Let me just check the name here. Yeah, thanks, Siddhartha, for your contribution. So let's look at the other PR that we have here. So is this another one from Siddhartha? Cool. Yeah, and this is another interesting case, right, where we have some divergence between the Groovy DSL and the Kotlin DSL, right? In this case, is not because of any special Gradle API or nothing like that. It's just the way, right? Java Bean property conventions, like naming conventions, work on these different languages. Work with it. So in Groovy, if you have a Bean property called is something, right? So in this case, is present, right? Groovy drops the is and just makes it like a single, yeah, just the what is this? The quality, the adjective, or the past participle. Sorry, my major is not grammar. So, but there's this difference, right, in the naming conventions between Groovy and Kotlin, and we tend, right. So our general guideline is that when there's no conflicting Gradle convention, right, we should stick to the native language conventions, right? Whatever is it's idiomatic Groovy, whatever is idiomatic Kotlin, right? So first, we should make things idiomatic Gradle, and then after that, we should concern ourselves with like idiomatic Groovy or idiomatic Kotlin, whatever the language we are using, right? So that's another interesting one. So in this case, the actual fix, right, apart from the differences in naming conventions across these languages, was that again, right, this common friend accessing the project object at task execution time. So do last runs during the execution phase. We're no longer allowed to access the project object because of, among other reasons, right? We don't want tasks to share any state, so we can be sure to run them in parallel, right? So we can know it's safe to run them in parallel because they won't be able to interfere with each other, at least as far, right, as we can tell by looking at the code, right? I'm pretty sure we can do some very nasty stuff involving like singletons or services. They make tasks interfere with each other, but we are doing a best effort here, analyzing the code and trying to avoid any chance, right, of introducing these interferences, any shared mutable state, like the project object would be in this case. So we're here, right? The snippet was trying to check if a certain property is defined, doing that during the execution phase. And we, again, moved the check to the, or not the check, but we capture, right? So this is interesting, right? Because we're checking a Gradle property. And now we have this new API for accessing environmental things, right? Including Gradle properties, environment variables, system properties as providers. So we do that, we create or acquire the provider during the configuration phase, and then we are free to use properties providers during the execution phase. So that's another general guideline, right? Whenever you try to access something, some piece of data at execution time, that is not allowed because it touches like a service maybe that is not supported, a project object, or a scripting, the scripting runtime, the script object. The rule of thumb will be move the access to the configuration phase and ideally capture whatever data or expression, right, computation you want to run in a property or in a provider, and use that at execution time. Because then what happens here, right, is that we are just acquiring a provider for this property during the configuration phase, but we only access the provider, right, at the execution phase. And that's important because we don't want to make these things that don't have to be, right, I mean, like these things like Gradle properties, environment variables, maybe files we're accessing, we don't want to make them build configuration inputs. That is, make them inputs to the configuration phase, because when they change, right, when their value change, Gradle would have to rerun the configuration phase. So by making sure we only access those providers at the execution phase, we can make sure they are not build configuration inputs, and then we get more cache hits, right? So that's cool. So thanks again, Siddhartha, for another contribution. So let's see this one. That's from Ricardo. Yeah, again, another case, right, of the configurations collection being used during the execution phase. And very similar solution, right? We move all those, like we basically capture each configuration in a variable during the configuration phase, right? During the register call. So in the do last call, we just access them, and that's perfectly fine. So yeah, thanks, Ricardo, for this one. And that's basically the same thing, just in a slightly different setup. So this is also involving like test suites, but in the end, the final test, it's basically the same, right? Configurations that were accessed. And this is a bit interesting one, right? Because we can see there was also a change here, right? So in the previous version of this snippet, we were doing like configurations.test runtime class path. But here we're doing like test runtime class path, like configurations.get by name. So instead of accessing the property directly, we're doing get by name. For Groovy, for the Groovy DSL, these are basically equivalent, right? They are the same. Just the implementation will be a little different, right? So in the Groovy DSL, we're gonna call this name here in the collection, where we're gonna try to access test runtime class path as a property of the configurations container. And then it's going to go through this method missing, member missing type of dynamic dispatching Groovy. And then the collection will return the configuration with a given name, right? So it's basically doing get my name, right? So this syntax should work here as well in Groovy. But we also have a general guideline, right, that we want the Groovy and Kotlin snippets, because they are displayed side by side in documentation, right? You can choose which one you want to see. We have a general guideline that it's better if they are more similar, right? It's better. So if we're using a particular API in Kotlin, and that's the case here, like this snippet in Kotlin, needs to use get by name, at least for these two instances. And because of that, we made a choice to also make the Groovy version similar in that regard. So that's another interesting one here. Yeah, it's the
This
same
one,
one. Yeah.
this one seems like a little bit cheat of a solution with the hard-coded file size equals 12 and 13. I'm surprised they didn't have a more elegant way to do that. Is there one, or why do you think they went with that solution?
Yeah, so in this case, this snippet is basically just working as a sort of test case. So it does expect a particular number of files to be in this configuration, right? And then a particular number to be in this configuration and all that. So that's just how the original author of the sample decided to structure it. And then, yeah, I guess people just didn't have a reason, right, to change it, basically, right? Because we're focusing on the configuration caching compatible parts. Yeah, I don't see anything else we could change here, or unless we want to change, right, the pros around the snippet and maybe restructure things a bit differently. Or were you thinking on something else?
No, that's exactly what I was thinking. It's just I kind of want to check out the git blame on that file now,
Yes.
but perhaps not, on a public YouTube.
Yeah. Yes. Let's not do that. Okay, moving on to the next one. Let me see. Which one is this? So this one is incremental task. Oops. So that's by Matthew. Thanks, Matthew. So let's take a look. Okay. So this is another interesting case. So you probably had to use one of these utilities once or twice in your life with Gradle. We have this project.file. So that's what's being called here, right? And when we are in the build script, right, when you're writing code in a build.gradle file or in a build.gradle.kts file, we can just use any members of the project object, as the project object is always in scope, right, uh, through the script. So that's what this snippet was doing before, right? We're basically using project.file. Even though we don't see project here, that's what's being called behind the scenes. And again, it's another instance of the project object being accessed during the execution phase, which is forbidden. So then what, right? Now we need a solution to replace that. And we have that particular case documented in our configuration cache documentation, right? When you have file or any of those basically layout or build layout related utilities, you should be using, right, the layout service instead. So here there will be different solutions, right? We could use different solutions here. I like this one because it kind of like does this dry step, right? Don't repeat yourself step to the snippet to make it like better engineered, right? So before we had this file inputs and then inputs slash inputs slash inputs slash, right? With the new solution, we use the service project layout service here, but just to capture the initial directory, right? That will be like the base directory here. And then we can use that to access the files in that directory. That's cool. And the other thing is almost sure, but not completely. So if anyone there knows, but I'm almost sure that this is unnecessary because Gradle will create output directories automatically, right? So that's why this can simply be removed now because the directory is already marked as a output directory. So that's all that's needed for Gradle to create the directories for us, right? And once we have that directory object, so here, right, a layout, project directory, they are all creating Gradle model types that represent these file system entities, right? So we have higher abstractions on top of like files and directories. So then to actually write something, we have to convert to a JDK file type so we can use the text property and then write to the file. So that's pretty cool. I like that. So the same here, right? We have this dry refactoring and then we can use inputs there. Yeah, another nice touch by Matthew was to then refactor this one task here to use one of the built-in tasks for deletion. Nice touch. So we don't actually have, right, to duplicate that. And even though it would be possible, right, to make this snippet configuration cache compatible without resorting to the delete task. But I think it's a better example now, like more real world, right? You want to reuse the built-in tasks. Yeah. So let's take a look at the Kotlin version. Pretty similar, right? So the only differences are really related to how you write to files using the native language mechanism, right? In Kotlin, you use write text. In Groovy tends to be more property oriented, right? You have the text property. But it's, yeah, pretty similar. Really like this one. Just really differences in the DSL, right? In Kotlin, we kind of abuse this idea of reify generics so we can simplify registration a bit of tasks, of elements in collections, right? It's a little less verbose when we use this reify generics facility. Yeah, that was pretty cool. So thanks again, Matthew.
I really think Matthews is a clever way to do it. It's a good solution, probably my favorite so far in looking at these. As I think about later on how I'm going to vote for my top 3, what are you thinking of as far as, how would you vote for your top 3 so far? Like we've looked through what, 4 different ones or 3 different ones,
Mm-hmm.
and what makes it shine to you, one versus the other?
Yeah, I really like when the changes, right? They follow these guidelines, right? Of using, for instance, the native language mechanism for each language, right? So when you are reading Groovy code, it reads like proper, idiomatic Gradle code and idiomatic Groovy code, right? And the same for Kotlin, right? So some contributors went, this extra mile to make sure the DSLs no longer not only look similar, right, consistent with each other, but they also consistent with the host language, right? And then I really like, and this things also like going this extra mile to suggest, using the delete task instead of reinventing the wheel in the sample, right? So
Yeah,
yeah, those are
it's a great way to look at it.
yeah. What about you?
I really thought it was kind of awesome that they rewrote that delete task, and just thinking about how many lines of code they were able to kind of remove and look at it. Because one of the things when I'm working on a project is I want the overall project to be more simple in the end. And if you could remove more lines of code than you add, then that's just awesome, because the next person coming into that will have a better understanding of what's going on.
Yeah, yeah, cool. So let's take a look at uh, Stefan's contribution. Let's see what this one is about. Custom DIRs. Mm-hmm. Yeah. Right. Yeah. So that's an interesting one. A very interesting one again, because it highlights another important distinction between the Groovy DSL and the Kotlin DSL, right? So, and you can see that already in the original version, and I particularly like that by making this snippets configuration cache ready, they are also much better showcases of the DSLs and all that. So kudos. So what's happening here, right? So again, it's a case of using the project object, right, during the execution phase. So as you probably know by now, we have to, you cannot access the project object during the execution phase. So anything that you read from that object needs to be read, or at least to be set up during the configuration phase, right? So in this case, we're reading, yeah, the root dir. So the root dir here, even though it doesn't say project, right, is that case where it's like implicitly using the project object because it's in scope, right? That's how the scripting works. We put this project in scope. You can access anything. So root dir comes from the project object. So okay, this one is simple, right? We just capture all the properties, root dir, reports there, test results there. We move them here, right, during the configuration phase. Okay, for Groovy, it's all good because Groovy, it's based on this idea of like, not that it's based on this idea, but like I said before, the syntactic sugar favors the eager configuration model. And also, it does some things that Kotlin does differently, as we can see here, right? So before, even this snippet was using the dynamic property lookup syntax, right? So every project object, in fact, all Gradle model objects, they can be accessed in a dynamic way, right? Using this idea of a dynamic object that we have. And in this case, right, we're doing like a dynamic property lookup in the project object to find the reports there and the test results there. Why, right? So what's going on here, right? So what's going on here is that behind the scenes, right, these plugins like the Java library plugin or the Java application plugin or all these plugins, what they do behind the scenes is that they contribute, among other things, right? They contribute tasks, they contribute other stuff, but they contribute these things we call extensions, right, to the project object. So here we can see we have a reporting extension that was added to the project object. And we have a Java extension that was added to the project object. And each of these extensions, there are like objects that can have extensions themselves or can expose properties, like reporting is exposing base directory, and Java is exposing test results dir, right? So what's going on here, right? The difference between these two DSLs in this particular regard is that in the Groovy DSL, the decision was made that any property of any extension, right? So like properties from the reporting extension of the project object, they should be visible in the extended object, project in this case, right? So that's why we can say project.reports there or project.test results there. It's because there is a extension, or they are also called or used to be called conventions at some point, in that object that exposes this property, right? So basically, this one layer, there is one layer here that the Groovy DSL hides, right? It compresses. And for the Kotlin DSL, we made the decision that all these extensions, right, all this extending business should be explicitly visible. And, and that also makes for simpler and better IDE support, right? Because then we can generate this thing we call accessors. So we can statically know, right, that the project has a reporting extension, and then we can go from there. So I can write a project dot, and then I can see all the extensions that are available, given the plugins that I applied to my project, and then dot, right, reporting dot base directory. So this dot completion business we are all used to do in the great IntelliJ idea, right, just works. So that's the difference here, right? So it's kind of not obvious, right? Like when you read it, you have to understand this extension model, right, behind the scenes.
So we got a question that popped up. Would it also work to access the properties of extensions using explicitly namespace members in the Groovy DSL, like like it is required in the Kotlin DSL?
That's a good question. Uh, I don't think so. We allow, but I bet you do know the answer. But yeah, I think we don't allow. Yeah, actually, we do allow, right? Yeah, so we do allow. Sorry, we do allow accessing via the extension name. So if I do like project dot reporting, you could access the base directory, right? So yeah, I think that would work. In fact, we could check that. So I'm gonna do something stupid.
Uh-oh, you're going off script, aren't you?
Yeah. So let's see what happens. So one thing that I didn't mention last time, but it might be important. So some of these samples, right? So they don't have the settings file in them. So when you try to import a sample in the IDE without a settings.gradle or settings.gradle KTS in the directory, it's gonna fail, because what happens is that the IDE is trying to discover like what's the root directory of your project, and it Gradle also, right, and it does that by searching for a settings file in the directory hierarchy, right? And so just make sure you always have a settings.gradle file before trying to import these samples. I'm going to use that trick that I used last time, now improved with a trick from Bjorn. Thanks, Bjorn, for that. So this is, I'm basically copying the Gradle wrapper from my root project into the sample, right? So I do that, and then I can just import that project now. Let's see. Yeah. So then the question is, right, can we use the name of the extensions, of the underlying extensions that expose those properties instead of the properties themselves, just like we do for the Kotlin version? So let's see. So in the Kotlin version, where's the Kotlin version? We're using the reporting extension. And for the other one, we use the Java extension. So let's do that. See what happens. This should be reporting. And this should be Java. It's interesting that they might now have even different types, because we might end up accessing slightly different members by doing that. That will be interesting to see. So let's see. I'm gonna just re-import just to make sure, just to see if it even works at all, right? Well, although this won't run, so it shouldn't be. That's pretty cool. You can see here that IDEA likes this, right? So IDEA knows that, okay, project.java.test results there is a directory property. Whereas before, right, it was a single file. So we can already see that we are accessing a different member here, right? Because since it's a directory property, I must call get here, right? That's what I must do, because this is a directory property. And then get, we return the directory, and then I guess I would have to do as file, just like the Kotlin version does, right? But let me just run this. Let's see what happens. I'm gonna run, oops. It's sticking, so let me try a different one. Gradle. Oh, it's not. So I'm gonna have to use the terminal. So I'm gonna run show dirs, right? That's one. So I'm gonna first just run without the configuration cache, just to see if we got the names correctly. That's all we need. Because yeah. So there's no report stir in the reporting extension. I guess that's the difference that I mentioned, right? So now, before we are using report stir, so that I can actually tell like the story about this thing, but I probably shouldn't. But what happens is that this report stir property, it's actually there in the extension. I looked, right? So like there is something called report stir here, but it just happens to be private. The thing is, Groovy doesn't care if a member can be dynamically looked up and it's private, right? Okay, if you're accessing that, you must know what you're doing, right? I guess that's the philosophy here. So this ends up being a kind of liability, right? Because now we have to keep this property, this private property, you know, laying around because of scripts like this. And with the new, right, when you actually access via like a statically typed thing, you cannot really see it. So I think that was base directory. Yeah. So if we try report there, we don't see it because it's private, right? Now we have types, so Groovy is happy to honor the types once you have them, right? And in this case, yeah, we would call base directory to be compatible. We would have to, again, this is a directory property, so we would have to see the cases and call like that as file. And that's the only one. Now it should work, right? Yeah, so now it works. And let's see if this solution will be also configuration cache compatible. So we see it has been stored, and now on the second run, it should just be reused and same thing. Yeah. So yeah, thanks, Paul. I forgot that it was actually the same model underlying. I thought the Groovy would be doing something funkier. So it's actually the same model. It's just that it has this ability to flatten, right, that extension layer away. Yeah, so there are a few things here, right? So it's nice that there's little change here compared to the original, but maybe we could make them more similar. Although, as I mentioned in the beginning, right, this is idiomatic Groovy DSL, I would say, and this is idiomatic Kotlin DSL. So from the point of view of the guidelines, I'm happy with this, and I'm also happy with the how they look the same in the do last. Right. Although we could simplify things a bit, and I think we're going to see a PR where where the contributor took like this simplification further. So let's go there. So this one is again from Stefan. Yeah, thanks, Stefan. Let's see. Dimitri. Mm-hmm. Thanks, Dimitri. I think I recall this one. Yeah, so this is another situation where we have, right? So if we look at the snippet before, we have project.file. In this case, in a custom task, so no longer like an ad hoc task, but the mechanics are the same, right? So this is a task action. It runs during the configuration phase. We don't want any project access during the configuration phase. So in this case, like project.file, we have already discussed, right, that the project layout would be a suitable replacement. And because the sample already, right, uses a custom task, I mean, a task that is defined as a proper class that extends a default task, we can use this injection mechanism, right? If you didn't know about that, that's a pretty cool and easy way to get access to the services to make your tasks configuration cache compatible. You can just declare, right, an abstract getter for any of the services that we expose as replacements to the project object and other objects that are no longer accessible during the execution phase. And that's it, right? So you inject, you declare the property, add the @inject annotation. Gradle will make that service available to your task, and now we no longer need to do project.file. We can add, so, and before, right, we had this project.file and then string interpolation, project.builder, right? So the new snippet makes proper use of the project layout.build directory property, right? And then can just access that particular file in there. And the rest is just the same, right? We're using with output stream, which is a Groovy mechanism, and list file sort. And also like just standard Groovy methods, so there's nothing important there. I recall, like, so this was interesting. We had a bit of back and forth during the reviews, because like the first solution that Dimitri came up with was actually a solution, right? Yeah. So that was the original. I mean, the first step, right, along the way, and which was to move, right. So instead of doing project.file during the execution phase, Dimitri moved, right, the project.file call to be just a property, a field of the task. So that's clearly then not running during the execution phase, right? Because tasks are instantiated or realized during the configuration phase. The problem with that solution, right, and I commented here, right, is that task instantiation time, right, is not particularly well defined point in time, and we're using lazy properties here, like we're using not lazy properties, but we're using like mutable state, like project.builder, right? So you might have, let's say, I instantiate a task, and then later some plugin or my own script, right, will go and changes builder to something else. And then my task will go and execute against the stale value, right, of that property. So you also need to consider, right, those details when moving things out of the execution phase to the configuration phase. So as long as you are using lazy values like this, properties, providers, right, should be all good. But there are situations where you need to put some more thought, because yeah, the obvious solution is not necessarily the best solution. And this was particularly important, right, with the list files call. So again, this does, right, make the task configuration cache compatible, in the sense that, okay, the configuration cache won't complain, right? You won't get a problem report and all that. But then, right, we're running list files during the configuration phase, which is not ideal, right? We want to, at least in spirit, right, this sample wants to do these things at the execution phase, right?
Yeah, I think there's another PR that was claimed already by Jeff that is very similar to this, and Jeff said that might help him if he watches this video or if he's on right now, because very similar logic applies. So this is really good that you pointed that one out.
Cool. Hey, Jeff, if you're watching this, pay attention. So yeah, so the other part, right, was then accessing, luckily, the same service already, right? So we already had like the project.layout. So that was a very natural, right, fix. And then, right, another case of accessing project at execution time that could be replaced by project layout. The Kotlin version, it's basically the same, right? Except that in Kotlin, you need to tell, right, the compiler that you're annotating the getter, right, or at least being more explicit about this, because so Kotlin allows annotations on the property, which would be like the getter or the setter or the backing field. In the case of an abstract, there will be no backing field, but it's good to be explicit anyway here, right? Paul, please correct me if I got some of these details incorrectly. Yeah, the rest looks exactly the same, right? Except that we're using more idiomatic Kotlin here. So we're using the output stream use and all that. The rest is just the same. Yeah, so that was it. So maybe I open this other PR. Let me take a look. I see here that the PR that Amanda commented is here. This one by Jeff. Yeah, exactly. Hmm. Yeah, it's basically the same, right? So it's the same. It's probably a task that was appearing in more than one example. Yeah, so Jeff, I would recommend you to use basically the same advice I gave Dimitri in the other PR, right? Um, because in this case, right, the builder. So what's happening here, right? Oh, it's so first, let me say that that's pretty cool, like nice touch, adding the annotations about like what's input and what's output. That's great. But the same caveat as before, right? Project builder is mutable. So even though, right, it's not common, and for like 90% of the situations, this would probably be okay because people don't change to configure builder uh, too often, right? To change builder too often. But this has happened at certainly during the configuration phase, which is good, but at in an unknown point in time, right? Is whenever the task is instantiated, and we want to have better control, right? We want to make sure whenever we actually use the builder value, right, the build directory is the final value that was configured. And to do that, we have to delay the call until the last possible moment by using something like project layout and directory properties and all that.
So we don't have too much more time. I know going through these PRs, the ones that were merged, was really enlightening for me to kind of see what people have done, and it was also reassuring to see how few things had to change to make them, stable configuration cache. And I know there's a lot of plugins out there that are currently not compatible with configuration cache. So is some of the ways that they made these compatible applicable to plugins, or what are some of
Yeah,
your
absolutely.
recommendations to plugin authors that you have out there?
Yeah, so in the configuration cache documentation, right, in the user guide, we have some of this guidance there, especially these things that I mentioned about how would you replace project.file and this project.utilities that you find, right, using services. So we have all this guidance there, and that definitely applies to plugin authors. Yeah, that's the cool thing, right? In the Gradle configuration model, basically a script is a plugin. So it's basically a plugin with syntactic sugar and all that, but it's basically a plugin. So all these recommendations apply. Plugins, they are kind of simpler, but not much simpler, but they don't have this implicit scope that sometimes makes it harder to see, okay, is this a project like when we had before, right? Just yeah, like this case, right? Just doing like file out of the blue, we just call file, or we say root dir, right? And then the configuration cache will tell, okay, you cannot access the project object. And they say, okay, I'm not accessing the project object, right? I don't see project here, but it's because it's implicit. With plugins, like with explicit plugins, I mean, plugins written as like classes and all that, you don't have this implicit scoping. So they tend to be simpler, at least to make the connection, right, between the configuration cache report problem you get and the symptom and the actual symptom. Right? Yeah.
So, and the goal is for us to have that stable configuration cache, soon. Do you think we'll be ready for Gradle 8 to be completely stable?
No, so it's not our plan to make bias. No, I mean this is not embarrassing in any way. It's just that it might not have been clearly communicated yet. But this stable configuration cache and the Gradle 8 timeline are not in sync, right? So we expect Gradle 8 to be full of like promotions and deprecations and all that, right? For things that were already in motion. And sometime after Gradle 8 is out, we're going to make a big splash with the stable configuration cache, but it won't be Gradle 8 just yet.
Oh, so they got to wait a little bit longer for it to be fully stable.
Yes.
Sorry, guys. Okay. So we still have 10 more issues to claim. That's, going down to the final end of it. Is there anything that they can do in the remaining 3 weeks beyond these issues to kind of move us forward for that stable configuration cache?
Yes, absolutely. I think one of the like main ways, and probably one of the easiest ways people uh, have to help us to contribute is to start using the configuration cache on their builds, right? Start like enable the configuration cache and let us know if you find anything that doesn't work as you expect, and like you can nag plugin authors in a good way, right, in a nice way, to make their plugins compatible with the configuration cache, and that will be like great already, aside from, of course, contributing to Gradle itself, fixing some of these issues or other issues that are bugging you personally.
Yep.
Yeah.
And how do they do that? Is there a good mechanism?
To enable the configuration cache, you mean?
Yeah. Well, I meant to reach out to us. So reach out to us on our Slack channel or on
Oh,
GitHub if you notice
yeah.
any of those problems with the configuration cache. And I think we are at time. So Rodrigo, this is really great for you to walk us through some of these PRs.
Cool. Yeah, it was a great pleasure. So thanks again to the community. They've been doing like great work. They've been very graceful with their responses during the code reviews and all that. So thank you very much. And thanks, Amanda, for being such a great host and helping us out.
Yeah, and I'll see everyone on Slack.